Chemistry itself knows altogether too well that given the real fear that the scarcity of global resources and energy might threaten the unity of mankind, chemistry is in position to make a contribution towards securing a true peace on Earth. Good day, everyone. I am Boncalon.
In chemistry, the more energy you put into a bond, the harder it is to break. I am Alcantara.
Every chemical reaction has a transition state. I'm Biadora.
Chemistry is necessarily an experimental science. Its conclusions are drawn from data and its principles supported by evidence from facts. I'm TIansay.
We are a chemical engineering student from the University of St. LaSalle, and we are going to discuss about how we would apply our learnings in chemistry in the field of chemical engineering.
What is chemistry? Chemistry is the science of matter. This may sound simple, but chemistry is a complex and broad topic that covers a wide variety of fields. From the core of the Earth to the farthest reaches of the universe, chemistry is everything and everywhere. Chemistry, a definition. Chemistry is the study of matter, including its composition, properties, and structure, how it changes, and how it interacts with energy. This is a pretty simple definition that sums up what is actually a complex and fascinating subject. If you have ever asked why or how something is in the natural world, odds are good that your question and the answer were related to chemistry. For instance, why is the sky blue? Colors depend on the chemical makeup of substances and what kind of light they reflect. How does an insect walk across the surface of a pond without falling through? The unique properties of water give it a high surface tension, which means that small objects can rest on it without sinking. Chemistry is all around, and anything related to matter involves chemistry. Main branches of chemistry. Since chemistry is such a broad and vast subject, we can divide it up into more manageable topics to help us more accurately. 1. Organic chemistry. 2. Inorganic chemistry. 3. Analytical chemistry. 4. Physical chemistry. 5. Biochemistry. We will learn more about these topics as we go on. What is chemistry? Chemistry is the science of matter. This may sound simple, but chemistry is a complex and broad topic that covers a wide variety of fields. From the core of the Earth to the farthest reaches of the universe, chemistry is everything and everywhere. Chemistry, a definition. Chemistry is the study of matter, including its composition, properties, and structure, how it changes, and how it interacts with energy. This is a pretty simple definition that sums up what is actually a complex and fascinating subject. If you have ever asked why or how something is in the natural world, odds are good that your question and the answer were related to chemistry. For instance, why is the sky blue? Colors depend on the chemical makeup of substances and what kind of light they reflect. How does an insect walk across the surface of a pond without falling through? The unique properties of water give it a high surface tension, which means that small objects can rest on it without sinking. Chemistry is all around, and anything related to matter involves chemistry. Main branches of chemistry. Since chemistry is such a broad and vast subject, we can divide it up into more manageable topics to help us more accurately.
As like what is said above about chemistry, chemical engineers apply the principles of chemistry to solve problems involving the productions or use of chemicals and biochemicals. They design equipment and processes for large-scale chemical manufacturing plants and test methods of manufacturing products and treating byproducts and supervise productions. Chemistry gives you a better understanding of the world. You can become a more informed citizen and make wise decisions about your environment by learning about the advantages and risks of chemicals through chemistry. Chemistry allows you to solve problems and interact with others in an ordered and logical manner.
Chemical engineers have a deep knowledge of chemistry, as their name suggests, chemical engineering. They need to master chemistry because it helps them to identify certain composition and products. It also helps them to understand the product even better by understanding its chemical composition. For example, the body lotion. Understanding its chemical composition allows the engineer to tinker the ingredients to get the best result needed. And also, testing the product isn't easy, especially when involving in digesting, wearing, smearing, and also for daily use. Safety is the best priority. Testing or using the product without proper knowledge could potentially lead to harm.
Also, chemical engineers work in a variety of manufacturing industries other than chemical manufacturing, such as those producing energy, electrons, food, clothing, and paper. For further information, let us discuss the following topics.
So first, let's start. How would we apply our learning in chemistry in the field of chemical engineering?
As we all know, chemistry is everywhere. Chemistry plays a role in everyone's life and touches almost every aspect of our existence in some way. Chemistry is essential for meeting our basic needs of food, clothing, shelter, health, energy, air, water, and soil. Now, let's explore the world of chemistry in the field of chemical engineering.
So first, let's talk about work. We basically define work as the energy used to cause an object move against a force. But in chemistry, work is a scalar quantity that is defined and measured by the product of the net force exerted and distance through which that force moves. For further information on how would we apply this in the field of chemical engineering, let's watch this video.
As dogs pull a sled through the snow, work is being done. Work is defined as the product of the force and the distance over which the force is applied. And since the work involves a transfer to energy, the units of measurement are joules. Let's say that the dogs are applying a force of 700 newtons to the sled, and they pull the sled for 900 meters. We can calculate the amount of work being done. Substituting values for F and D and multiplying them together, we find that the work that the dogs are doing is 630,000 joules. When a plane lands, work is done to bring it to a stop. Force is applied to the plane to slow it down, through the friction of the wheels on the ground, the friction on the wings, and, in extreme circumstances, hooks and straps to bring it to a rapid stop.
Chemical engineers also involve the transfer of thermal energy from one object to another. This is due to a temperature difference referred to as heat. Heat always flows spontaneously from hot to cold objects. It is important to note that heat is not a type of matter. Atoms, molecules, and ions are the tiny particles that make up all matter. These small particles are always in motion, either colliding or oscillating back and forth. Heat or thermal energy, which is present in all matter, is created by the motion of particles. Heat may either be sensible heat or latent heat.
Professor Dave here. Let's talk about heat.
He knows a lot about the science stuff. Professor Dave explains.
We are all quite familiar with the concept of heat and can describe the sensation of feeling too hot or too cold. But understanding what things like heat and temperature really are on the molecular level can be pretty tricky business. Nevertheless, we must fundamentally understand them as a prerequisite to learning about thermodynamics. So let's dig into this abstract concept. We can start with temperature, like the temperature outside today. It might be hot, it might be cold, but in science, we want to quantify everything that we can. So saying something is hot or cold just isn't enough. We want to be able to say how hot or cold with numbers. But that begs the question, what is it that temperature is physically measuring? Temperature is measuring the amount of heat energy available for work in a system. And heat energy is related to the average kinetic energy of the atoms and molecules within that system. We know that greater kinetic energy means objects will move faster, and this is true of molecules in the atmosphere just as it is of macroscopic objects. So higher temperatures simply mean faster moving particles. This kinetic energy of motion is distributed amongst translational or side-to-side motion, rotational or spinning motion, and vibrational motion, where the covalent bonds in a molecule bend and stretch. Heat will flow from hot objects to cool objects because as the particles move, they will impart some of their kinetic energy onto other particles through collisions. This will continue to occur until the whole system is at the same temperature, in a state called thermal equilibrium. This is how thermometers measure temperature. Heat from the environment will be in contact with the thermometer and flow into the thermometer fluid, causing the atoms to gain kinetic energy, and the column will expand until it is in thermal equilibrium with the environment, thus allowing us to read the temperature in one of our man-made units. We must bear in mind that all phases of matter expand with higher temperature, whether solid, liquid, or gas. This phenomenon is called thermal expansion. Energy is transferred as heat in a wide variety of processes. When a collision occurs, there is usually some heat generated. Friction can cause heat as well, which is why your hands warm up when you rub them together vigorously. In each case, we are considering the kinetic energy of the particles and the transfer of some of this energy to other particles as the definitions of heat and heat transfer. Heat is therefore a kind of energy in transit and will be measured in joules just like any other kind of energy. Furthermore, the transfer of heat energy will always alter the temperature of an object, as heat will always flow from the higher temperature object to the lower temperature object until thermal equilibrium is reached. This is why hot objects feel hot and cold objects feel cold, because a hot cup of coffee, which is hotter than your hand, will transfer heat into your hand, while a cold piece of ice, which is colder than your hand, will cause heat to be transferred out of your hand and into the ice. These events produce the hot and cold sensations we feel in our day-to-day lives. Now that we better understand heat and temperature, let's check comprehension.
The process by which chemical energy is changed into electrical energy or vice versa is known as electrochemical energy. This comprises redox reaction and electron transfer processes. When a material receives one electron, it is reduced. When a substance loses one electron, it is said to be oxidized. Electricity, to put it simply, is a form of electrical energy created by movement of electrons. It is an electrochemical cell. A chemical reaction at one electrode generates electrons, which subsequently flow to the other electrode and are consumed there. Numerous typical uses of electrochemistry can be found in daily life.
Chemical processes are employed by all batteries to produce electricity, including those that run flashlights, calculators, and automobiles. Plates made of ornamental metals like gold or chromium are applied to items using electricity. In today's civilization, electrochemical cells are crucial, particularly for energy storage. It is possible to employ electrochemical cells such as batteries to store energy from sporadic energy sources like the sun and wind on a large scale. An atom's nucleus, which is made up of protons and neutrons, releases energy in the form of nuclear energy. Fission and fusion are two processes that can be used to create this energy source. Fusion occurs when two nuclei combine. The fission of uranium atoms, also known as nuclear fission, is the source of nuclear energy. As a result, heat is produced which turns into steam, which then turns into electricity and turbine generator. Nuclear energy plants don't release greenhouse gas emissions because they don't burn fuel. Contamination of air owing to the presence of compounds in the atmosphere that are hazardous to the health of humans and other living creatures or cause damage to the climate or materials is referred to as air pollution. At the end of the 18th century, scientists realized that relationships between pressure, volume, and temperature of a sample of gas could be obtained that would hold to approximation for all gases. The nuclear technologies today rely heavily on chemical engineers to make the machine work, since the processes in nuclear industries require extreme training and understanding of their work. Their work includes the uses of elements, proper waste management, radiations, safety protocols, knowing the right reactor, fusion reactor, fuel processing, and fuel chemistry.
The Greek word stoichion, meaning element, and metron are the source of the word stoichiometry, meaning measures. Calculations involving the masses and occasional volumes of the reactants and products in chemical reaction are the subject of stoichiometry. Stoichiometry is the area of chemistry that involves using the relationship between reactant and a product and chemical reaction to determine quantitative data of interest. In chemical engineering, stoichiometry is used by engineers to know how specific material and chemicals react to one another. This is also used to measure the specific amount of material needed to produce the desired amount of product produced using the equations. This is also used in the composition of daily life products like shampoos, conditioners, perfume, and etc.
In chemistry, a solution is a homogeneous mixture of two or more compounds in their relative proportions. The compositions of the solution can be continually changed up to the solubility limit. Although solutions of gases and solids are possible, the term solution is most frequently used to refer to the liquid conditions of matter. In chemical engineering, mixing chemicals are often done in this field. So by learning using solutions, chemists are able to mix chemicals and other mixtures with predictable outcomes, knowing the possible.
The branch of thermodynamics known as thermochemistry examines how heat and chemical reactions are related, because it may be used to predict whether a given reaction will take place and whether it will release or absorb energy as it does. Thermochemistry is a crucial area of study. It examines the heat energy involved in chemical processes or phase transitions like melting and boiling. Both a phase transition and reaction have the potential to use energy, release, or absorption. Numerous items are used in daily life such as engines, batteries, refrigerator, etc. We're used using thermochemical principles in order to predict whether a specific reaction will take place and whether it will release or absorb energy as it does so. The field of research known as thermochemistry is crucial.